Hi, thanks so much. I'm so excited to get to talk about my favorite thing for an hour this morning. So, thanks for joining me, and thanks to Patton. The supports that you all provide to Pennsylvania, but then that you make available openly to everyone are fantastic. And I use them in my courses and recommend them frequently. So, thank you for all you do to support the field, not just in Pennsylvania, but broadly. So as I said, my name is Dr. Jenny Root. I am the Ann and John Daves Endowed Professor of Special Education at in Ann's College at Florida State University. Um, so the topic today that I want us to spend about an hour talking about is how do we make math meaningful, accessible, and joyful for all students? So starting with some questions like I'm going to walk us through. So the first thing, well, what makes math meaningful? What makes it accessible? And what makes it joyful? I think perhaps it's the training in special ed or the behavior analyst in me, but when we have these, I'm very particular about words and the words that we use and thinking about what do those really mean and what does that look like. So we're not going to be getting like operational definitions here, but it has gotten my mind thinking like what are the indicators that something is accessible and or joyful or meaningful. So let's start with this one. I want you to take a few seconds to think about in the past 48 hours, how have you used math? And try to go beyond just purchasing things or paying bills. So I know for myself, I always joke about having to do backwards math, calendar math. So if I knew this was starting at 8:15, I wanted to be sitting at the computer at 8 o'clock. I wanted, when did I need to get up? When did I need to make sure that I took my ADHD medication to make sure it kicked in, right? So that is sequencing and math and estimation, right? So I want you to hold on to that. So, as special education teachers and general education teachers, math, I think we would all argue and agree with by the fact that we're all here at 8:15 on a Wednesday morning in June, that we find math incredibly important. But teachers have all kinds of content areas that we need to cover. And this says nothing about how I view literacy. Literacy is very important, but it gets sort of the lion's share of attention as in our teacher preparation programs, in professional development offerings, often in the amount of instructional time that's dedicated to it. And yet, special ed teachers, we also have all these other skills that we're supposed to address in addition, right? We have self-determination skills. We need to build language and communication, pro-social behavior. I was a middle school teacher and I spent a lot of time on hygiene and personal care and social skills, right? But math impacts every one of these areas, right? The daily living skills, that calendar math, hygiene and personal care, thinking about dosing medications or how often to do something, self-determination skills as far as setting realistic goals. So math can be meaningful in so many different areas of our life. But all those things that we want, our ultimate goal for what we want students to be able to do is generalize the math skills that they learn in school. But we can't just teach for acquisition and hope for generalization. And what I mean by that is particularly when students struggle with math or have identified disabilities, there are so many skills that need to be targeted, even just within math. And we think about, where are we going to get the most bang for our buck? Where do we need to have, prioritize, considering we have perhaps less resources and the same amount of time as any other teacher in class. And so often we teach students, we get them to acquisition, and then we move on and we just hope for generalization. Unfortunately, I think we also do this in teacher preparation and professional development. But what we need is not just for students to acquire math skills, but they need to become fluent in them. They need to be able to apply them in a way that doesn't draw so much on their cognitive load. They need to become fluent. That's when the math skills begin to become useful. Then they need to maintain those skills over time. And all of that needs to take place in order for them to be able to generalize those skills. So think back to those examples that you just identified of how you've used math in the past 48 hours or so. And I would argue that most of the examples that you're given, based on me having done this exercise dozens of times with teachers and faculty and students across the country, I would argue that probably what you identified was problem solving, right? You first had to know there was a problem, or I think it was just goal-directed behavior, right? I wanted to be here for this on time this morning. Um, and so in order to get here on time, I needed to choose a strategy, you monitor your progress, and you make changes. Um, that requires this metacognition and flexibility, um, which is our ultimate goal, right? So if we want students to be able to actually use the math skills we teach in school, we need to make sure that we're teaching in a way that is going to take them through those stages of learning to be able to generalize and apply in problem solving settings, everyday settings, because there's no way that we could actually teach, every variation of how they might need to use a skill. So if being able to use math to solve everyday problems makes math meaningful. So that would be if I had to come up with this definition or criterion, the math skills we teach in school are only useful if the students can use them. Is this true for everybody? Right? So coming back to the title of the presentation is, how do we make math meaningful, joyful, and accessible for everyone? So is it true that everyone, in order for anyone's math to be meaningful, they have to be able to use it? I appreciate this quote, and I come back to it often from NCTM's equity statement, where they've said too many students, especially those who are poor, non-native speakers of English, disabled, or members of racial or ethnic minority groups, are victims of low expectations for achievement in mathematics. And unfortunately, there are so many students, and I myself will talk later about how I have been a perpetrator of this crime, of low expectations for students based off of my own insecurities, biases, and self-assessment of who needs what type of math. So for many students, and particularly those that my research focuses on, which are students with autism and intellectual disability who take the state's alternate assessment, they are caught in this sort of double bind of low expectations, where often in early elementary grades, grade aligned math is not a priority for a variety of reasons, right? It might be that they had challenging behaviors that really limited how much attention and instructional time they could receive. Might have been more focused on communication and pro-social skills at the time. Variety of reasons. I think one of them that we often don't acknowledge is teacher decision making. And like myself, our own assessment of who needs math, like who needs which math. So we have this, it's not an instructional priority. But then at the same time, when we look at teaching grade aligned math, we say, oh, well, they're not ready for that. They don't have what we have as pre-skills, the prerequisites, which I always think about what Lou Brown said, which is pre means never. So we have many students who are caught in this bind of it's not an instructional priority, but then they're not ready because they don't have the skills. So if being able to use math to solve everyday problems is what makes it meaningful, in order for it to be meaningful for everyone, it has to be accessible to everyone. So not only does every student need to have the opportunity to learn math and the opportunity to meet high expectations, but they also then, that instruction needs to meet their needs so that they can acquire and generalize those math skills. Okay, so if everyone needs to access it, what makes it accessible? What is the criteria that we should be aiming for? So what I want you to do now is I want you to think back to a vivid math learning experience. Okay, it could be positive, it could be negative at any point in your own learning. So thinking about yourself as a student. I want you to try to close your eyes. You're probably by yourself, so it's fine. And picture that scene. So I want you to think about what was the teacher or the teachers in the room? What were they doing? What was it that you were expected to do? I want you to think about what materials were you using or the teachers using? And what did it feel like? Because if a learning experience is vivid, then that's going to have some sort of emotional connection to it. And then how did you feel after that math learning experience? So just kind of put that in a bubble to the side. So I firmly believe in the applying the least dangerous assumption, and when it comes to instruction and students, and that we need to only focus on the alterable variables. Again, coming back to my training as a behavior analyst, we have to focus on what are the instructional variables that we could manipulate uh, in order to improve student outcomes. And from that perspective, if the student isn't learning, if the behavioral outcomes aren't what we intend for them to be and they're not meeting the goals, we don't question the student's ability first. I think most often we wouldn't just assume like, oh well, they have autism, so they can't do it, right? Or well, they do have a learning disability, right? We need to be focusing on what are the instructional levers that we can push or pull in order to increase that student success. And while I think very few people would, I'd say, admit or claim or stand firmly in saying, nope, I think about what the student is doing wrong, or maybe the student just isn't capable of it first. I don't think any of us consciously and explicitly think that way. But I wonder if this is happening in an unconscious way, that we are using our biases and perhaps ableist stereotypes and assumptions about, again, who needs to or gets to uh, learn math, instead of first thinking, well, what is it about the instruction? And then I added, and the environmental demands and supports that is causing the student to not be successful. Where is the instructional failure happening? And I think this then leads me to how I view any of us and our success, right? So if we ask like, oh, is that student able to, um, you know, add and subtract fractions? Is that student able to count with one-to-one correspondence? Is that student able to do math? Um, I think that we have to be aware of the context within which all of this happens. And we can't assume that people are like stable, consistent beings. We shouldn't have higher expectations for children than we do for ourselves, or that the environment is the same all the time, right? So when your personal competence and the demands of the environment are perfectly aligned, life's good. Sometimes your personal competence hasn't changed at all. You haven't had some traumatic event happen, but sometimes the demands of the environment are raised or changed. And I think the most pressing example was the school closure and shutdown during COVID in 2020, right? Where all of everyone who was teaching then, you had the same skills you had before, but all of a sudden, what it took to do your job to teach students it immediately went up. Now, for some of us, maybe if you're already used to teaching online, that wasn't a super big lift. Maybe for those of us in higher ed, I'm used to teaching asynchronous online classes. It wasn't a huge difference. But for classroom teachers and for students, this was a really big difference, but it had nothing to do with their own skills changing. There are other times where the demands of the environment stay exactly the same. It's our personal competence that fluctuates. And this is related to my comment about us having different expectations for students and children, particularly those with disabilities, than we do for ourselves, where we expect them to um, sort of be robots also, that we're overly focused on compliance and are they doing what it is we're asking, regardless of how they feel. Um, I equate this to teacher behavior when, how good was I at teaching? How easy was it? How much tolerance did I have? How much irritability did I have? Varied throughout the day and throughout the week, right? The way I might react internally to something on, Tuesday morning at 10 a.m. It's very different from Friday afternoon at 1 p.m. Right? There's also the fact of taking medication changes our cognition or the way that we're able to process. It impacts our emotional reactivity. We're all people who have things that happen to us. People have bad days, right? So the environment can stay the same and our competence can fluctuate. So I would argue then math instruction is accessible when there's alignment between an individual's personal competence and the demands of the environment. So meaning that when the students' math skills, when the task, when the supports, when the instruction are aligned with the student's skills, then they're able to be successful. They have the opportunity to even access that math instruction. So I'll ask again, is this true for everyone? Both, is it true that there needs to be alignment between these? And is it true that that's a goal we have? So from my perspective, we need to sort of accept two things. I have two things is one, environments and systems are disabling. So you could take the exact same student and put them in different classrooms, different teachers, different curricula, instructional strategies, all those alterable variables. And some of those might help the student and some might be detrimental. So by knowing that and believing that we as the adults and the instructors can improve student outcomes by changing those instructional variables, we're then also admitting that we can make a choice that results in students not being successful when we don't alter the environments or the systems or the learning task. At the same time, individuals have unique and dynamic profiles of capabilities, limitations, and support needs, right? So every person is an individual. And so for some, an environment might be totally supportive of them and aligned with their needs. And for others, it's not. And that's not necessarily stable over time, right? And that's what makes teaching really hard. So from my perspective, it's disability. When we think about students who require specially designed instruction, it's in order to address that mismatch between their learning environment and their personal skills and competence. So instead of coming from this more deficit-based, like, well, is that student able to blank? Instead, I want us to think about using a more strengths-based approach where we ask ourselves, well, what supports does that student need in order to do the task, right? How is the environment, the supports provided, how are those need to be adjusted in order for that student to be successful? So instead of saying, well, and again, this is coming back to my own unconscious biases when I was teaching, instead of thinking like, well, who needs to do math? Everybody. This says everybody needs to be able to do math. If it relates to daily living, social skills, fine and gross motor, mental health, not to mention literacy, right? It's not who needs to learn math. Our question now is who's going to get to learn math? And is everyone getting the opportunities to access math so that that math can be meaningful? And the answer is no. I love this quote from Jose Filson that says, there's a lot of people right now who've been given permission to be innumerate because society has deemed innumeracy as okay. As long as you're not a math person, it's perfectly fine to fail math. And, if we were in person, I would ask you, like, raise your hand if, you don't consider yourself a math person. Probably less in this room among friends. But in general, it's much more accepted to say like, oh, I'm just not a math person. I'm not good at math. in a way that we would never say, like, I'm just not a reader. I'm not good at reading. There's a sense of shame that comes with that. I don't think it's appropriate. Um, but it's just factual that there is a different response to those two things. And um, as I'll talk more about in a minute, it was my own um, insecurity in math that then influenced what I prioritized and taught to students or thought should be taught. Because again, everyone was getting access to reading instruction. I spent twice as much time on reading as I did math. So, if alignment between this personal competence and demands of the environment is what makes math accessible, then I would conclude only if math is accessible does everyone have the experience, the opportunity to experience joy in math. And this might feel like something very disconnected. I don't know that up until the past 2 years or so, I had really even read or heard or thought about joy and the affective aspect of math learning. But as the new UDL framework came out and it emphasized joy and play, I kind of dug into that and tried to um, move beyond my initial, like, huh, what, that doesn't make sense. Um, and now I'm fully bought in, and let me try to convince you. So, what makes math joyful? Well, so I immediately go to the internet and Google. So here's some screenshots from various like Webster, dictionary.com, Wikipedia, right? Where I was like, well, what does joy mean? Words matter to me. And so I started getting several different definitions. So joy is a person or thing that causes happiness. It could also be something or someone greatly valued or appreciated, or a source, excuse me, a source of um, a reason for valuing or appreciating something. It brings you joy. It's an emotion evoked by well-being, success, good fortune, prospect of possessing what one desires. And I was like, oh, that's self-determination language, right? That's thinking about goal-directed behavior and you know, being able to have opportunities to do something and the capacity to do it well. And then in Wikipedia, they said it's closely related to, evoked by well-being, success, or good fortune, right? So joy is not synonymous with happiness. Happiness is about the individual moment. Um, uh, you know, and enjoying an activity or being happy, that's a sort of a state of being and that fluctuates. Joy is not the same thing as happiness or gratitude. It is that this emotion that comes along with being able to do something, right? It's a hopeful, future forward focused emotional word. And so it's as I was starting to look into these definitions that I thought, okay, this is making more sense. Saying that if math is joyful, it means that an individual sees it as something meaningful, something that helps them uh, reach their goals, to be successful. They feel like they have well-being. They value this, right? It's you don't have these types of feelings if you don't feel capable. So I want you to go back to that vivid math learning experience that you identified a few moments ago. If you want to close your eyes or think back. How did you feel about math at that time, if you can remember from your perspective now? Did you always feel that way? Or did your feelings about math change over time? Does that memory represent an unusual or uncommon learning experience for you in math? So was it vivid because it was sort of this outlier, either of a positive experience or outlier of a negative experience? Think back, like what did it feel like to be in that room and how did you feel afterwards? So, If you have a scrap piece of paper or something around you, you might want to get it out, or you can set up a graph in your mind. I will never know what you do, what you do. But I want you to set up a graph that has a scale of 5. And on the bottom, you don't have to label these, but I want you to think about that x-axis as time periods in your life. Okay, so you want a graph with a scale of 5. And then again, you don't need to write out these. I just want you to think of it as sort of the periods of your life. So this is mine. And now I want you to sketch, if you've drawn it out, or just kind of imagine drawing it in your brain. How would you describe your math confidence at these different time periods in your life? So anywhere from like very confident to not at all confident. So sketch out, what did that look like? Was there variability? Think through it in your head, like, what would that data uh, path look like? Now I want you, if you're using a pen or something, maybe a different color, or color of the line darker or something. But I want you to now also think, how much did you enjoy math over time? Was it something like, I always enjoyed, I looked forward to that class every single day, my entire life. That was my uh, happiest learning activity, to I never enjoyed it, I hated it all the time. So I want you to think about, what did that look like over time? So here's my math confidence over time. And I'll walk you kind of through it. So um, again, this is all from my recollection now, with a little bit of triangulation, talking with my parents. Um, so in preschool to early elementary, I felt capable and smart across the board. I enjoyed school. School was easy for me. In fact, in first and second grade, I was sent to the grade level above for math and reading, because they didn't have gifted. And although we would know now, like, it's not the appropriate way to provide enrichment, that's what they did, right? And that gave me this sense of like, I mean, I obviously knew me and one other student are going to another grade. I'm good at math and reading. I can remember in third grade, Mr. Rowan, um, I was having trouble with multi-digit multiplication. And she showed me, she's like, here, I think this will make sense. And she showed me the lattice method. And I took it home and showed my parents, and I was so excited. It became a bit of a family joke, with my multiplying with boxes. But this method made sense to me, and it bolstered that confidence. Then I go into fourth grade and hammering multiplication, and I can see it vividly, the bulletin board that had like a popcorn bucket for each student with their names on it. And then we did math time multiplication fluency tests. And for each fact family that we memorized, and scored whatever we were supposed to on the time test, we got a popcorn kernel with that number on it. So you could visually see, everyone in the classroom could visually see how everyone else was doing. Truly don't think the teacher knew maybe like what impact that would have. I believe everybody does the very best they can with what they know. But for me, I was the last student in the class to fill my popcorn bucket. And we had, after lunch each day, this time to practice math fluency and take our test. And then once we were done, we could read our book, which was honestly all I wanted to do, was just get to reading the book, our like silent sustained reading, independent reading book. And so it was very self-managed. It was like a 25-minute time block after lunch, and it was up to us. Practice, do your test, move to the next thing. Well, guess what I did? I didn't practice. I would just take the test and then get to reading my book, right? So I don't think it was an ability of mine to memorize those things. It was not of interest to me. at the time. But then I became so far behind. And it was kind of conflicting too, because I was at that point going to a gifted class for like math and reading enrichment. But then here I have this visible reminder every day of how all my classmates are better than me. That was my perspective. We then move into middle school, and particularly in seventh grade, I remember getting B's and C's um, in math, and I truly did not understand. I also wasn't paying attention. It was very much the let me do some problems for you on the overhead projector. Hope you're paying attention. Do it independently is my recollection now. And I was probably reading a book under my desk, or not paying attention, or talking, or doing something. All right, so that really made me dislike math, right? I was not confident at all because I wasn't learning it. There's no reason to be confident. Um, and then sort of the culminating event was, or experience was in eighth grade, when I was put into Algebra 1 in eighth grade, despite poor grades. But I would get fours, the highest level on our state tests. So I went into Algebra 1 and I failed. I failed the first quarter and my schedule was changed. They then put me back into eighth grade math, and that my whole rotation changed. And it was incredibly embarrassing. It was awful. And from there, it just firmly like, I'm not good at math. I don't like math, but it's okay because I'm really good at writing and I'm really good at reading. So then going into high school, that influenced the courses I took. I um, went to a higher performing middle school than my local middle school was, that was much more challenging, about 45 minutes away. So then I was coming back to my home high school. And I remember my brother saying, like, you have to take honors classes. Like, what? You're not, what do you mean you're going to take regular classes? But I thought, no. I was like, you don't understand. I'm not good at math. I can't be in those classes. I was so afraid of like failing again. Um, and then when I got into the classes, uh, I didn't do great, but I was doing better than the others, and that gave me confidence. Honestly, it sounds terrible. Um, but then again, I'm still getting these fours on the state tests. And then I go into my undergrad, and I tested out of having to do math. I never took a math class in college. It wasn't required. I was just able to take math for elementary school teachers. It was the only one I needed. And by that point, I knew I wanted to teach students with autism. I thought I wanted to be in a self-contained setting. And I truly said repeatedly, I don't need math. I don't need math to do that. Those students aren't going to be learning math. This more advanced math, I'm fine. But then I took a direct instruction math class and realized like, oh, like teaching this can be really fun. And I was good at it. I then, in my first teaching job, was a resource language arts and math teacher. And so I had to take the gen ed middle school math praxis. And I was very nervous about it. I was nervous about teaching math. I studied. And then when I got to the test, it was fine. I did fine. I remember when I was applying to my master's program, intentionally choosing to take the MAT because I thought I didn't need math. And I was terrified to take the GRE. But then when I was applying to doctoral programs, they only accepted the GRE. So I bought the whole set of books to practice. And I realized I didn't know a lot of the math. I had to teach myself, but it wasn't that hard to teach myself. And I realized like maybe I am fine at math. I scored way higher than I thought I would. But I just kept going back to this like identity I had built for myself of I'm not a math person, I'm not good at math. I then go into the doctoral program and I would work with my advisor, Diane Browder, and she says, like, I just got a new grant that we're going to be working on to develop a math word problem solving curriculum for students with autism and intellectual disability. She was like, I think she said something along those lines of, how do you feel about that? Well, I feel great. I'm excited, right? I'm not gonna tell her I'm not a math person. I'm not good at math. And through that process of developing that curriculum, learning about schema-based instruction, I realized more fully where my the instructional failure was. I realized that I did not develop a conceptual understanding of uh, uh, the relationship between math concepts. And that lack of that early on and a significantly negative experience then totally closed my mind off to lots of possibilities. I then took a faculty role, and by this time, my research is I am all in on math word problem solving, moving into multiplication, multiplicative problem types, extending beyond what we did before. And I would still, not say I'm not a math person, but I would say, my expertise is in instructional design, and I'm applying it to math. My expertise is using ABA to figure out how can we alter those instructional variables for success. And there's other people, my research team, doctoral students, who they're my math person. So I kind of still had this lingering identity. And then in my early 30s, as a tenured faculty member, I was diagnosed with ADHD. And when I got that diagnosis, I was like, no, no. I was like, you don't understand. I have 3 degrees in special ed. I know what ADHD is, and I don't have it. And the provider said, yes, you do. And I think you just don't know what it looks like. We haven't talked about what it looks like in um, gifted girls. And I can look back and see, oh, like that the stupid popcorn buckets and the time tests, that wasn't interesting to me. I wasn't motivated by that every day. I just wanted to get to the fun thing. I was not able to delay that. And in many other ways. Similarly, when I learned the lattice multiplication method, I never multiplied multiple digit numbers any differently. It was not until I was a faculty member that I really learned some of the other standard algorithms for how to multiply multiple digit numbers after I had a PhD. And so looking back, this started to make more sense as to why I wasn't being successful. And then I was visiting my parents, and they were cleaning out closets and stuff. And my mom had put this box of materials together, like pictures and report cards and things like that. Um, and it was so interesting. I found old report cards, old uh, printouts from standardized tests. Show you, for example, 3rd grade, I was getting A's in math. I was indicated as being above grade level towards the end. I scored in the 98th percentile. So I was not bad at math. The instructional experiences that I had, I was not successful in those. And then I got this whole identity as I'm not a math person. But that's okay because I'm a girl and I'm good at these other things. And I'm going to be a special ed teacher and I don't need a lot of math anyway. So then if I took my sketch of my math enjoyment over time, which I did kind of do separately and thought through the time periods and realized, pretty unsurprisingly, they're related. So again, this is my anecdotal sort of takeaway, was that my confidence in math influenced how much I enjoyed math and my career decisions. So be curious if your mental graphs or the graphs that you've sketched are similar or different from this experience, from my experience. And really where I can see how those earlier negative experiences that really killed my confidence then totally influenced my career decisions. It influenced what courses I took in high school. It influenced, I think I would have majored in what I majored in. I don't think that it was that detrimental, but it definitely impacted how I viewed it. Um, it influenced what tests I took, what graduate schools I applied to. And most certainly it influenced the decisions I made about my students and what math they needed, how much of it, what their goals should be. So this relates to this Thomas and Barry quote that says the ways that students experience math instruction influences how they identify themselves as doers of mathematics, right? So I want to come back to these asterisks of, I don't believe that I had math anxiety. I think that is a real thing. I'm not talking about that necessarily. I never felt this like anxiety over doing the math. I felt social anxiety about being like found out that I wasn't good and didn't know because I had built my whole identity on like being the person who was good at school. So my takeaway from this is that feeling successful and capable makes math joyful. We're not going to be joyful about something that we don't feel capable to do. So is this true for everyone? Is it true that we even want math to be joyful for everyone? Is it true that we think that's a possibility? Can every student feel successful and capable in math? And I would argue yes. And students can tell how we perceive a content and how we perceive them and what our expectations are for them. And there's many different ways we signal our expectations, um, perhaps unconsciously. So we think about the words that we use to talk about ourselves, to talk about math, talk about other students, the goals we set, and the supports that we provide. So when we think about the words that we use, and might hear like low functioning. I truly detest the conceptualization of high functioning and low functioning, but we hear that term, they're low functioning, or oh, but they have, they're on the alternate assessment, or they, are nonverbal. And that then qualification there is used to lower expectations. Or are they just not achieving right now, not because of some inherent quality of theirs, but because of where instruction has been? I do want to say the caveat that we're not expecting every student to, master every grade level standard or, to reach the same level of math proficiency. That's just not realistic. I'll talk about in a minute how variability is like the defining feature of being human. But every person deserves the opportunity to be seen as someone who does get to learn math. So instead of this sort of external locus of control view of, well, that student's low functioning, that I'm communicating to you by saying that word, that they don't have the ability. So what's the point? Why are we spending time on that? When again, we have so many other things that we're supposed to be teaching. Or are we seeing it as an instructional failure? This instruction isn't working. What might be the cause and what are some of the solutions? Where is that mismatch between the environment and their personal competence? Are there things in the environment or the learning task? Can we scaffold it differently, break it down, change instructional strategies to make it more accessible to them? And then also, what are the skills that student still needs to develop? What are the things that we need to provide to enhance their personal competence? Because it's coming from Marty Snell. And in addition to their collective diversity and need for lifelong supports, all share a fundamental human trait, and that's the capacity to learn. Unfortunately, as I said earlier, there are many people for whom the adults in their lives, often very early on when they were very young, determined that they didn't need math, which really was not true, because from my perspective, hopefully convince you that we all, the math has the potential to be meaningful for everyone, but that they weren't going to get to learn meaningful math, because it's like we have this perspective of, on one hand, we have kids on a destination towards, yes, they are going to need to use math for all those other things. And then we have students that, nope, we act as if they're two different destinations that they're working towards. And so when we think about inclusive opportunities and supports, why would we have people riding in the same car if they're going to two different directions? They're going to two different destinations. So I think identifying what are our goals for students, for all students, needs to happen first before we think about where they're going to learn. And this comes to the criterion of the least dangerous assumption. So this is quite a word twister. This is from Anne Donnellan in 1984. And she said, in the absence of conclusive data, that's a really important piece. So like when we don't know, educational decisions ought to be based on assumptions which, if incorrect, will have the least dangerous effect on the likelihood the students will be able to have enviable adult lives, was my editorial change. So again, so when we don't know, when there's an absence of conclusive data, we need to think about what are the consequences of our decisions and which one of those, if we are wrong, is the least dangerous to that student. That the collection and the use of data and making data-based decisions is critical. This isn't just magical thinking, just putting everyone in the same classroom to learn the same things out of a sense of social justice. It's not that. It's making sure they all have the opportunity and that we're collecting data and that we're thinking what supports do they need in order to achieve those things. Because ultimately, what Eric Carter talks about as what means a meaningful adult life, what are the things that we're hoping for? We want students to feel a sense of belonging in their community. We want them to have a meaningful work, fulfilling relationships, opportunities for post-secondary training. I don't want to misrepresent the importance of math. Lots of other factors contribute into these. But your math proficiency is going to impact all of these areas. So instead of thinking about who's going to need math and like which destination are we going to, I want to think about, well, who gets to learn it and who gets to decide that and when. So instead of this seeing two different destinations, what if there's lots of different life outcomes and ways that people, goals people might have, ways they may need to be able to do math. And my point is that the adults should not be determining, especially so young as it happens with students with intellectual disability and autism, what they're going to need to be able to do in their adult lives, particularly considering the technology advances. And I think it's kind of hard for us to even picture what the demands will be and the opportunities will be in 2032. So is our instruction preparing them for this unknown future, or are we preparing them for what we were prepared for in 2002? What we should be aiming for all students is mathematical proficiency. What this looks like and how we provide instruction to this is going to very much differ based on those individual learning profiles. But we should have this goal, and all students should have the opportunity to receive high quality instruction using evidence-based practices in order to develop each of these really important skills. And to do that, again, signaling what are our expectations for students, what are our supports for students, they all need to have a consistent opportunity to learn contextualized, grade-aligned problem solving so that we have a problem-solving focus, that we're focused on that generalization and transfer and application of skills. It's aligned to their chronological, age-appropriate grade level, and it's taught within a meaningful context to them. In addition, particularly our students who are already identified with disabilities, we need to make sure that their foundational numeracy skills are adequate. If students are not able to count with one-to-one correspondence, then and make sets of objects, then they aren't going to be able to be independent in using manipulatives, which is a critical tool to give them to access modeling higher levels of mathematics. So those foundational numeracy skills are going to need to be worked on beyond, the first, second grade standards. But over time, there's going to be less of that. We're not using that as a gatekeeper, but we're continually working on building the foundational numeracy skills. At the same time, it's important that we focus on personal applications. Another word that perhaps could be used for that is functional skills. I personally think everything we teach should be functional. If it's not, why is that an instructional priority? And if you want to hear sort of more about my soapbox of this, you can check out my recording from yesterday's presentation, where we dove a little bit more into this. So as students get older, we then have more of a focus on that personal applications and preparing them for to make sure they're prepared for their post-secondary goals and what they're doing next. So all of this is under the assumption that we are anticipating and expecting variability, that there's going to be variability, intra and interperson variability, right? That the skills and that I have, the supports that I need are going to vary based on the task or the environment, they're moving. And that also it varies among people, which again is part of what makes teaching so hard, but also for my brain so fun, is that we have this natural variability. And so we can use the UDL framework to help make sure that we are proactively considering the variability of the students in our class and proactively planning for how to make sure that the math is accessible and that they are feeling competent and are set up for success so that they can feel joyful. So the components of the UDL framework, which UDL is not an evidence-based practice, and no matter how many, if there were greatly designed, methodologically rigorous studies on UDL, it just wouldn't make sense because it's not a specific practice necessarily. From my perspective, it's a framework for thinking about what practices to use based on a systematic way of thinking through the students you have in your classroom and trying to mitigate or prevent instructional failure. So we want to think about, how can I make sure every student stays engaged in learning? Can I make sure that every student is able to perceive and understand the information I'm giving and that they can show what they know? So everything that we do should be grounded in the science behind the why, what, and how of math learning. We should be using evidence-based practices. We should be continually updating and being willing to question and change our own decisions as we get more information, that we're willing to take in that information, that you're doing what you all are doing now, attending professional development, so that we are using that to drive instructional decisions. But within that, we can use the UDL framework to help anticipate variability so that we can make our instruction as efficient and effective as possible. And I think it's important for teachers especially, but also teacher educators, to understand deeply that how children learn math, how does math develop, learning sciences, so that when they go to change their instructional decisions, they're done so based on the best information that they have. For example, the most recent What Works Clearinghouse practice guide in math that was focused on intervention in the early grades. This was based on a review of research with students who had or were at risk for mathematics difficulties. So these were not students with autism and intellectual disability or extensive support needs. But that doesn't mean that these practices don't still apply. They very much can and do, which might need to be done in maybe a more intense way. But we should be using these practices and then considering how can the UDL framework help to make it more accessible. So just as very brief examples of how we can use the UDL framework to think about our explicit instruction that we provide, right? Which is our foundational instructional strategy. How, making sure that we have those clear expectations and the progress is visible to the students is going to help them stay engaged. Thinking about Okay, we need to have lots of examples and non-examples that are modeled and students have the opportunity to respond. That's representation, thinking about how are we breaking that down into manageable components. And then how are we supporting students to show what they know? Um, and doing that by how do we reduce the cognitive load, and we're creating predictable routines, giving step-by-step instructions. So this is just one brief example of how we can apply um, evidence-based practices and UDL, and they're complementary and not competing. So I want to end today with just a recap of my proposition or my assertions. And that is that being able to use math to solve everyday problems is what makes it meaningful. But to be meaningful, it has to be accessible. Math is accessible when there's alignment between the personal competence and the demands of the environment. And when it's accessible to everyone, everyone has the opportunity to experience joy, which is that feeling of being successful and capable. So thanks so much for joining. I hope that you were able to access the handout. It has my email, so feel free to reach out. And it also has, importantly, a link to um, uh, publications that myself and my uh, research lab have done. So if you don't have access to Teaching Exceptional Children or some of the other journal articles, you can go to that link and access those for teaching and instructional purposes. So thanks so much.